Hello everyone, I'm Dr. D. Suresh, Assistant Professor from the Department of Automobile Engineering. So in the last session, we discussed on the topic Introduction to the Modern Automotive Technologies, where I covered in terms of why we need the advanced technology, or maybe what is the need for the adoption of technology into the vehicle, and what are the parameters which are making for uh, drive for incorporation of the technology into the vehicle. So as we discussed, the basic parameters is the drivetrain technology, and chassis technology, and interior technology, and body technology, where the places we can improve the or maybe adopt the technology for uh, better comfort, as well as safety, as well as to meet the government regulation. These are the driving factors which forces for the technology development. Based on that, we identified the four places, that is drivetrain, chassis, interior, and body, where the technology adoption we discussed elaborately in the last class. And we also gave some introduction about engine electronics, what is open loop, what is the closed loop, and what kind of what is the percentage of these electronic components inside the vehicle, what is the cost associated with that. So those parts we covered in the last session, and today's session we are going to discuss on some of the important things related to the SI engine management system, that is spark ignition engine management system. So based on that, these are the overview we covered, what are the engine variables and parameters. With the help of this control system development, electronic engine control, so with the variables we are able to change it, not parameters. The parameters are fixed one, these are fixed during the engine design itself. These variables which we will control it, so this controlling by this inputs and outputs, in relation to the outputs we can control the inputs, so that we will get maximum fuel economy and minimum emissions. That part we discussed in the last session. So today's session, just we are going to discuss on engine management system. So that is also we give some of the introduction related to the what is the basic purpose of engine management system. So this basically responsible for controlling the amount of fuel being injected and for adjusting the engine ignition timing. So this is the basic purpose and motto of introducing the engine management system inside a vehicle. So the basic intention I mentioned, so that once we give the optimum or maybe controlling the fuel amount, then which will ensures that minimum emissions and maximum fuel economy. So that's why the optimum functions of EMS ensures the maximum engine power with the lowest exhaust gas emissions and lowest fuel consumption. In order to get this objective, we are introducing the engine management system. So same way, the two functions which we discussed in the last class, and these are the role of engine management system. This is also discussed in the last session, and these are the parts. If you take an engine management system, it is divided into three categories, that is input section, and controlling unit section, and output section. So the input section basically the sensors, there are various type of sensor depending upon the kind of system we are dealing with, where the sufficient number of inputs are needed for uh, taking or maybe analyzing in the control unit. The control unit basically a brain of this control system, so that is electronical control unit, engine electronic control unit. So based on these input parameters, the output may be regulated, or maybe whatever kind of output we needed, for that we will monitor the inputs, so that we can get a in input and output relation, uh, in a drive to a maximum fuel economy and minimum emissions, if you consider or taking as example as a engine. Okay. So the different uh, different kind of systems, if you take it like engine management systems, like MPFI, that is multi-point fuel injection system, and gasoline direct injection system, and CRDA system. These are the most common, or maybe technologies which are available at the current market. So these are the systems are developed to achieve two things maximum, that is two things always I am mentioning, that is to achieve maximum fuel economy, minimum emissions, maximum power output. So in order to achieve these three things, we adopted these three technologies. If you take any kind of this technology, either mpfi or maybe gdi or maybe crdi, common rail direct injection system, so the basic structure of these systems is same. Only thing is the operating conditions, the kind of architecture is only the different, but the controlling system is the same. So how this control system will be there? If you take that, these are the sensors and what they will do, and actuators what they will do, and control unit. This part also we discussed in the last session. And coming to this session today, basically if you take an SI engine management system for this session, uh, basically, so if you see the central portion which we discuss is a engine portion. This is conventional engine part. This particular area is completely an engine area. So this is mechanical part, that is basically it's related to the uh, piston, that is piston connecting rod arrangement, and seventh is a spark plug. Here we noted down in this picture, spark plug, piston, connecting rod. So all these parts are just a fixed parts. With this we can't vary it. We can play with in terms of variables, the variables which we mentioned, like mass flow rate of air, or maybe mass flow rate of fuel, and ignition timing. So these are the variables. With this we can play it. So in order to operate an SA engine management system, as we discussed in the starting of this session also, we have input parameters and output parameters. The input parameters and output parameters, in between that we have a control system is presented. So here there are n number of sensors which are the input parameters for an SA engine management system. So typically these sensors will be present from input to the output. So these sensors will give the information to the electronic control unit, that is engine control unit. It will analyze the information. Based on the information from the different sensors, the arrows towards the ECU, these are the inputs. All the arrows towards direction towards the ECU will give the input parameters. And if you see the output parameters from the engine control unit, very limited, that will be given to only some of the sensors, like output sensor, that is engine fuel injector sensor, that is fuel control, that is only the output sensor. And another sensor, maybe if you see that, there will be another sensor, that is ignition system. These are only two outputs, the remaining all are inputs. If you see, the input parameters will be in terms of mass air flow rate and mass fuel flow rate, and also some of the other conditions, like if you take in a coolant system which is needed for a particular engine, so for that we have a coolant temperature sensors. So like that we are going to see a different kind of sensors here. Typically the names include here TPS, that is throttle position sensor, and MAP, this is nothing but manifold air pressure sensor, and MAP, manifold air temperature sensor, and CLT, coolant temperature sensor, and cam angle and TDC sensor. So the cam is nothing but basically it is used for at what time I need to open and close my input and output valves, and input and output valves. So that's a basic thing. And TDC is nothing but at what time, or maybe the location of the TDC, top dead center, when it is achieving, while the piston is moving from TDC to the BDC. When the piston is reaches the TDC, then the signal will be reaches based on the position sensor. Apart from that, we have an engine speed, that is in terms of RPM, at what rotations per minute it is rotating, and spark ignition is output, and oxygen sensor, this is present especially in the exhaust, how much amount of oxygen which is present inside the exhaust gas. So that's why you can try to see. So when the air from the atmosphere which is entered while starting off your vehicle, when you press an accelerated pedal, so the air from the atmosphere will be entered due to the vacuum which is present inside the engine. So that we discussed when maybe we know, when we understand the basic working principle of the engine. So when we press an accelerated pedal, so we are able to start my vehicle. So at that time the vacuum which is present inside this manifold or maybe engine will attract some amount of air because of the pressure differential. That's why the before entering the air from atmosphere, it will be passes through the air filter first, where I can able to filter any kind of unwanted particles which are present inside the air. So if it is reaches into the engine, that may lead to a some kind of unwanted or maybe some kind of unwanted emissions that should be avoided. So that's why we are able to eliminate some kind of unwanted particles with the air filter. Once it is processed through this intake manifold, through this passage, it will be entered into a intake valve. Through the intake manifold, which is entered into intake valve. So when the valve is open, the intake valve, so it will be entered into the piston, so that entered into the engine cylinder, that we know. So but before it is entering into the air into the engine cylinder, we are going to take some of the inputs about, or maybe some of the health or maybe characteristics of that particular air. So first one is the throttle position. So before, when you press an accelerated pedal, obviously we are releasing this throttle valve. How much the throttle valve is open, whether it is completely open 100%, the valve is nothing but just like in a passage, just a circular hole. If you assume that the throttle valve is just a circular valve, so if the circle is open 100% or maybe 50%, 25%, 10%, or maybe 12%, 13%, so based on that, the position will be sensed by the throttle position sensor. If the more open, the throttle valve is completely open 100%, then it will give the information to the engine control unit. It will understand that for 100% throttle opening, it will give some kind of, or maybe it will analyze some kind of information for a proper output. The output may be here two only, the fuel flow and ignition timing. So it can adjust the outputs, or similarly based on this output, it can instruct, or maybe, so based on this input, it can instruct the fuel injector to inject it based on the throttle position. That is one way. And similarly, not only this throttle position, but also you can see the number 3, that is here we mention intake manifold. So 3 is an intake manifold, the air which is passes through the throttle valve, which is entered into a intake manifold. So where I can take the information about the sensor, that is the pressure. So what is the manifold air pressure sensor inside that? So based on this sensor, I can able to analyze some information. If the manifold air pressure is very high, it can give some information, it can analyze some information. If it is low, it can understand something. That means if manifold air pressure is very low, that means the valve is open very slow, very small. If the manifold air pressure is very high, then the manifold pressure is equals with the atmospheric pressure, so that way is equal to the atmosphere. Based on this throttle valve position, also you can assume that what is the manifold air pressure. If the manifold air pressure is response, like the pressure is equal to the atmosphere, then you can understand that the throttle is open 100%. So just we are uh, uh, correlating these three sensors. So if the information comes through to TPS and MAP are matches, then ECU will take some information, that is correlation between these two, the position as well as the pressure inside the manifold, are both are gives some kind of same kind of analogy to the ECU. So for manifold air pressure sensor, it will senses pressure inside the manifold and given the information to the ECU. Similarly, manifold air temperature, once it is entered into the manifold, what is the temperature of the air? So the pressure and the temperature will decides what is the density of air which is entering into the engine. If the density if it is high, then it will analyze some kind of information and it will give them a proper output to the in terms of fuel injector as well as the ignition timing. So similarly, coolant air temperature, so at what temperature the coolant is maintaining. If the temperature of the coolant is very low or maybe high, so based on that, it may supply very it can actuate, the ECU may actuate it, the motor which is corresponding to the coolant supply more or maybe less RPM, or maybe less liters per minute, more liters per minute. So it will give the information about that. Similarly, cam signal and TDS signal. So at what time the intake is opening, at what time my intake valve has to be opening, at what time the piston is reaches to the TDC. When the piston is reaches to the TDC, then only we can open the intake valve. That is actually theoretical manner. The piston reaches to the 100%, that is TDC signal, so then only the intake valve should open. So that is the ideal condition, whether we are meeting that ideal condition or not. Similarly, at what RPM the engine is running it at current status. So, and similarly, what is the at current status, what is the level of oxygen inside the exhaust manifold. So based on this, I can able to decide it. Based on these several input parameters, it can analyze the information. The ECU will analyze the information for understanding all these sensors input, whether all are gives a proper kind of input. For this proper kind of input, what kind of output I need to give the information to the fuel injector. So at what time the fuel injector has to be open, how much time it has to be open, and at what time it has to close it. So how many times the injector has to be open during the combustion process. All these things it will give the instruction to the engine flow. So got the details in terms of the ECU will instruct the fuel injector in terms of at what time it has to be open, how much time it has to be open, how many times it has to be open, and at what time it has to be closed at each opening. So all these things the ECU will give the instruction to the fuel injector. So then the injector will act accordingly. The fuel injector will act accordingly. Similarly, it will also instruct the ignition at what time I need to ignite the fuel, how many times I need to ignite the fuel, at what time I need to ignite the fuel. So these are the things it will instruct by the ECU. The ECU will take a multiple number of inputs, and it will take a multiple number of inputs and giving two outputs. So those will be the, from this picture, if you understand that, those will be the fuel flow or maybe the fuel injector injection and also ignition timing. These are the output. If you understand clearly an SI engine management system, just I would like to conclude by giving the statement: the SI engine management system is works on a number of sensors inputs which can characterize or may be responsible for a good health of an engine, for getting maximum power output, minimum emissions. So in that particular context, it is taking a number of inputs from the different sensors. Those includes throttle position, manifold air pressure, manifold air temperature, coolant temperature, engine speed, spark, that is oxygen sensor, and cam signal and TDS. These are the various number of inputs it will take it and analyze the information and provides two proper outputs, that is fuel, how much amount of the fuel it has to inject it, how many times it has to inject it through the fuel injector, at what time it has to close it, and at what time we have to ignite the mixture. So that's about the through the spark ignition. So from this picture, same thing I can explain in terms of analyzing through the driving. So when you press this, if you try to see, when you press accelerated pedal, obviously you are opening the throttle pedal. So that's why all these functions will starts, working will starts when you press accelerated pedal. So the main intention is here, as we discussed and discussing also again, that to get maximum fuel economy, minimum emissions, high power. So all these things will be stop and starts when you press accelerated pedal. That's a basic common point. Same structure I will explain through a sample graph, SI engine management system through a block diagram. So from this you can try to understand the number of sensors. This is varies from manufacturer to manufacturer, but in a general way I mentioned, first is the throttle position. When you press accelerated pedal, the throttle will be open. So at what position the throttle is open? So when you press the throttle, then the air from the atmosphere through the air filter, it is entering into the intake manifold, where I can able to understand mass airflow through the pressure and temperature, based on the pressure, that is manifold air pressure, manifold air temperature, air temperature. Based on those two sensors input, the ECU may calculate the mass airflow. Then that's why you can say manifold absolute pressure, then engine speed, cam position, that is the TDS signal position, engine coolant, and exhaust gas oxygen. All these sensors will give the information to the ECU at pinpoint time. For every second it will, or maybe for every microsecond also, they will continuously monitor. The ECU will analyze the information from these sensors and gives the information to the actuators, that will be the fuel metering, that is your fuel injector controller, and ignition timing, that is the basic kind of ignition system. It's maybe um, a magneto ignition system, or maybe electronic ignition system, any kind of ignition system. It will give the information to the ignition timing system, that is ignition electronic ignition system. And exhaust gas recirculation valve, how much, this is also another controller. If kind of technology we introduce in the latest, so based on that we can, some kind of exhaust gas will be recirculated for better combustion to get maximum output with the minimum emissions. It's a basic thing. And further, if you see the input to the controllers, say mass airflow rate, manifold absolute pressure, and throttle position sensor, and engine speed, and angular position cam sensor, engine coolant sensor, exhaust gas oxygen concentration. And the output to the controllers, as we discussed, fuel metering, that is fuel metering control, that is fuel injector control, and ignition timing and spark timing, that is electronic or maybe conventional ignition systems, and exhaust gas recirculation. And if you see the working same, which are the things I mentioned in the picture, same I quoted in terms of the statements, we will see. So electronic control system mainly consists of engine sensors, just V sensors as an input, and electronic control unit and fuel injectors. The fuel injectors is the outputs, that is actuators, and assemblies and related wiring for transfer of the information from sensors to the ECU, and ECU to the sensors, and sensors to the actuators, and actuators to the ECU. And ECU will determines how much fuel needs to be delivered by the injector by monitoring the engine sensors. That is based on the different engine sensors, it will analyze the information and calculate how much amount of fuel I need to supply to the engine. So how this is precisely calculated or maybe determined by the ECU. So the position of the throttle bed sensed by, so that it will give the information to the fuel injectors. So how basically it will be works, the position of throttle bed sensed by the throttle position sensor, so which directly regulates the airflow to the engine, thereby controlling the power output that we mentioned already. So air enters to the air induction system, where it is measured by the airflow meter in terms of volume, or maybe in terms of pressure, or maybe in some of temperature. This method is called direct mass flow air measurement. If you do that, so that means if there is any mass airflow sensor, or maybe volume airflow sensor, if it is directly kept into the passage of manifold of engine manifold, then it is called direct mass flow measurement. This is right now we are not using, we are using only indirect measurement, that is based on the measurement of manifold absolute pressure and engine RPM and inlet air temperature. So this will give you a precise information to the ECU in terms of at what flow rate the air is entering, so at what density the air is entering. So this is nowadays we are using, that method is called indirect mass airflow measurement. The direct mass flow air measurement initially we used it as one of the technology, now we are not using it that. So instead of directly measuring the volume flow and the mass flow, we are taking the indirect measurement. So based on this, fuel injectors are arranged in the intake manifold behind the intake valve. So these will get the information from the ECU how much quantity of the fuel they have to inject it. So these will be operated with the electrical solenoids which are operated by the ECU. And the ECU will pulses the injector by switching the injector ground circuit and on and off. So the ECU will communicate the same information, how much time the injector has to be open. So based on that, the injector solenoids may start giving the injection, so in terms of the pulses. So the pulses will be in a way, so that frequency in a second time, how many times I need to open it. In a second time I need to open 200 times or maybe 300 times, and each pulse will give some amount of injection of the fuel. So when the injector is turned on, it opens and spraying the atomized fuel and backside of the intake valve. Okay, so it mixes, once we sprayed it, it mixes with the incoming air and vaporizes due to the low pressure in the intake manifold. So as we know, for an SI engine management system is we need a homogeneous air and fuel. So when you operating uh, when you are supplying the homogeneous air and fuel mixture, so then we will get a maximum power output. Before that, you need to remember one thing: the engine needs air and fuel. So the air is in terms of gaseous initial stage, but the fuel, if you take, is a petrol, which is in terms of liquid state. So there are two difference in the phases of the two fluids. So that means we need to convert this fluid, that is the fluid, that is petrol, into a air, that is the gaseous form, as soon as possible, so that before entering into the engine, so that we will have a sufficient time for mixing of air and fuel, that is petrol, so that we will get a maximum power output, or maybe maximum conversion of the fuel into a power. So otherwise, if we are not able to blend or maybe mix properly this fuel and air before entering into the engine, so there is a possibility of not conversion, or maybe maximum conversion is will be decreases. To avoid that, we are going to be mix very we have to fix, blend, or maybe mix 100% homogeneous manner before entering into the engine. That is possible when you inject the fuel with high pressure. When you inject the fuel with a high pressure, it is uh, atomized very fastly and convert into a gaseous form, that is vaporized due to the low pressure and intake manifold. So basically the ECU will operates, always ensures that to maintain ideal air to air fuel to gas ratio, that is 14.7:1, that is stoichiometric air fuel ratio. The stoichiometric air fuel ratio should be maintained by the ECU. What is meant by stoichiometric air fuel ratio is basically what is the amount of fuel is needed, or maybe what is the quantity of air is needed for complete combustion of the fuel. So if we need one particle of fuel needs 14.7 particles of air. If you supply more, then it will be lead to more oxygen in the exhaust. If you supply less, then less amount of oxygen in the exhaust. That is called rich and lean mixtures. So when you supply 14.7:1, if you supply 14.7 kg of air per 1 kg of fuel, always this ratio should be maintained for kg, for an half kg, for 100 gram, for 5 gram. So like that, this conversion should be, the ratio should be always maintained by same 14.7:1. That ratio should be maintained. If you maintain that ratio, we will get ideal combustion, or maybe maximum combustion efficiency, so that I will get without any wastage of the fuel. So for complete conversion of the fuel taking place, from fuel to the power, maximum utilization of the power without limiting, without drive to any kind of unwanted exhaust emissions. Okay, so that ratio should be maintained. The ECU motto is here. The ECU motto inside a SI engine management system is to maintain this 14.7:1, and also maintain a proper ignition timing. Proper ignition time, at what time I need to inject the fuel. If you inject the fuel properly, then only it will be, even though you maintain 14.7:1, if you do not inject or maybe ignite the fuel properly, then it also leads to unwanted emissions and less, maybe more fuel consumption. To avoid that, we need, the EC will ensures both. Okay, so basic injection quantity based upon the measured intake air volume and speed. So based on the how much, what is the throttle position, if you open 100% throttle, then ACU will understand that there is a maximum amount of air is coming, so that I need to open a maximum amount of time for the fuel injector. Okay, maximum number of times I need to open fuel injector, maximum quantity of the fuel I need to inject it to achieve maximum speed. When you open throttle 100% means the driver is intended to go with high speed, or maybe whether he want to overcome a large load on the road, so that the ECU will instruct the injector to supply more fuel, whether it may leads to a high speed or maybe leads to a overcoming of a high load on the road. Clear? So that's why depending upon engine operating condition, so injection quantity will vary. The ECU monitors the variables such temperature, engine RPM, throttle angle, so exhaust in oxygen content, and makes the engine corrections which determine the final fuel quantity. For example, for an instant I open, for 2 minutes I open around a throttle valve for 100%. So some way I overcome the load, or maybe some way I want to reduce my speed. So then what I will do, I will release my pedal, my leg on the accelerated pedal. So when you release, or maybe when you try to decrease the accelerated pedal position from moving away from your pedal, so you will leave your leg, so that the throttle position comes from 100 to the 50%. So at that time the ECU will understand the throttle position comes to 15%, 50%, then it will adjust the uh, injection correction, so that it can adjust the injection timings, how at what time I need to inject and how much time I need to inject, and what is the quantity of the fuel I need to inject it. So based on these two inputs, that is such as coolant temperature and those, based on those it will do it. That's a basic thing. So before going to the session will be in terms of what kind of sensors which are present inside this engine management system, how they will be works, what is the basic sensors which are available, and what is the basic working principle behind that. So those sensors we will discuss in the next session. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.